Day 532 of doing a LeetCode problem every day until I get a job. All right, y'all, we're back again. Another day, another LeetCode problem where we're doing daily LeetCode problems. And today we have question number 3003. Maximize the number of partitions after operations. The difficulty level is hard, but don't worry because you already know we're going to keep the solution as simple and easy to understand as possible. But before we get started, y'all, don't forget to like, hype, subscribe, comment, and share. And if you need any new Apple AirPods, go ahead and check out that link in the description so you can get you some. Now let's see what the question says. You are given a string S and an integer K. First, you are allowed to change at most one index in S to another lowercase English letter. After that, do the following partitioning operation until S is empty. Choose the longest prefix of S containing at most K distinct characters, delete the prefix from S and increase the number of partitions by 1. The remaining characters, if any in S, maintain their initial order. Return the integer denoting the maximum number of resulting partitions after the operations by optimally choosing at most one index to change. All right, y'all, so that may seem a little bit confusing at first, so let's go ahead and take a look at these examples just to make sure that we are doing this problem correctly. So, in example 1, we have our input S equals a string A, C, 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 A, and K equals 2. The output is 3. Explanation says the optimal way to change S is to change S of 2 to something other than C. For example, B, then it becomes ACBCA. Then we perform the operations. The longest prefix containing at most 2 distinct characters becomes AC. We remove it and S becomes BCA. Now the longest prefix containing at most 2 distinct characters is BC, so we remove it and S becomes A. Finally, we remove A and S becomes empty, so the procedure ends. During the operations, the string is divided into 3 partitions, so the answer is 3. All right, y'all, so let's break that down one step further just to make sure we completely understand what's going on. So let me go ahead and copy this input. Let me just copy and paste this whole input over here so we can see what's going on. So we have K equals 2. So that means we can, when we are doing our partitioning, we need to, our partitioning operations, we can only remove up to 2 characters or 2 distinct characters in the prefix. And what distinct means is the characters are different. So in this case, A and C are 2 distinct characters because they are different characters, where this right here, CCC, is not distinct because they're all the same characters. They're not unique. Every character is a C, so that's not a distinct character. But A and a C, those are 2 distinct characters because they are 2 different letters. So what we want to do is we want to change one of the letters in here so that we can denote the maximum number of resulting partitions, right? So in the example, they changed this C to a B. So let me copy and paste this again. Boom. So we changed this C to a B. Now you can see that's a game changer because remember, we're talking about distinct characters, right? And at first, these 3 characters are not distinct. So that would mess up our partitioning operations when we got there. But now we have distinct characters. These 2 are distinct. These 2 are distinct. And these 2 are distinct. Since K equals 2, we only need every other character to be distinct, right? Because K equals 2. So we just can't have 2 of the same characters or letters in a row. But so that's why this wouldn't work, because it's 3 letters, 3 of the same letters in a row. But when we switch it to B, now that's a game changer when we do our partitioning operations, because now we could do our first operation. So K equals 2. So we get the prefix of this. First we change the letter. Boom. We change the letter to B. Now we're left with this string right here. Then we look at K, which equals to 2. So we remove the first 2 or the longest prefix of S that we can up to 2. And in this case, we can do 2. So we just take these 2, remove it. Boom. Then we take these 2 and remove it again. Boom. That's 2 operations. Then we could just do this. Boom. And in total, that was 3 operations, right? So let's take a look. If we didn't change a character, let me just show you how it wouldn't work if we didn't change that character, right? So we would do this. Boom. We would delete those 2. but then we wouldn't be able to go any further, and we wouldn't be able to delete the whole string because these two characters are, or these two letters are the same. They're not distinct. So that would mess up everything, and we wouldn't be able to delete them because they're the same characters. So that's why it was important to change this C to a B so that we were able to delete the whole string. Boom. So now let's take a look at example 2. Same principles apply. In example 2, we have the input string equals S, or yeah, the input S equals a string AAB, AAB, K equals 3. The output is 1. Initially, S contains 2 distinct characters. So whichever character we change, it will contain at most 3 distinct characters. So the longest prefix with at most 3 distinct characters would always be all of it. Therefore, the answer is 1. So let's see what they mean by this. It says initially, S contains 2 distinct characters. So those 2 distinct characters are A and B. Those are the only 2 distinct characters that we have, right? So then it says, so whichever character we change, it will contain at most 3 distinct characters. So let me copy and paste this over here, right? Boom. So whichever character we change is just going to make it 3 distinct characters, because right now it's only 2. So say we change this, now we have 3 distinct characters. Or say, oh sorry, let's put that back. Boom. Or say we change this one. Either way, we're left with 3 distinct characters, right? So then it says the longest prefix with at most 3 distinct characters would always be all of it. Therefore, the answer is 1. So in this case, K equals 3. Boom. So we would just get rid of that. Boom. So now the question is, that's the only operation we could do. Like, we can't do anything else because these are not distinct characters. So it's really nothing else we can do. We just have to, that's the only operation we can do. So that's why the output is 1, because after we do that one operation, we won't be able to complete any more operations no matter how we look at it. Boom. So now let's take a look at example 3. So in example 3, the input S equals a string X, X, Y, and Z, K equals 1. The output is 4. Its explanation says the optimal way to change S of 0 is to change S of 0 or S of 1 to something other than characters in S. For example, we could change S of 0 to W. Then S becomes W, X, Y, Z, which consists of 4 distinct characters. So, excuse me, y'all, so its K is 1, we'll divide it into 4 partitions. So once again, I'm gonna copy and paste this over here. This is pretty simple though, y'all. It's boom. So that's what we started with, but since K is 1, we would only be able to delete 1 character at a time. So let's just say, like they said, S of 0, we're gonna change S of 0 to a W. But K equals 1, so we can only delete 1 at a time. So we delete this W, that's 1 partition. Then we delete this X, that's 2 partitions. Then we delete this Y, that's 3 partitions. Then we delete this Z, and that's 4 partitions. And that's how our output became 4. Boom. So with that being said, y'all, now that we understand the question, let's get into the fun part, the actual solution. The solution is not that difficult at all. So let's get into it. Now, hold on, let me get rid of this first. Boom. Now, the first thing we want to do is we are going to create a constant. So we are going to say, let char, we're going to say, let chars equal an array square bracket, so not square bracket, parentheses S. So what first thing we're going to do is we are just going to turn S, this S right now is a string. We are just going to convert it into an array, and we're going to store it in chars. Boom. Then we're going to come underneath this, and we are going to say let n equal chars.count. Boom. Then we need a memoization dictionary. So the key index, the key is the index bit mask or the use change, and the value is the maximum partitions achievable from this state. So we're just going to declare a variable, call it memo, and set that equal to dictionary of string. So the key is going to be a string, colon, the value is going to be an integer. Then we're going to initialize it with parentheses like this. Boom. Now we need a helper function to count how many distinct characters are in the bit mask. So we're going to say func bit count. Boom. We're going to open up the parentheses, say underscore mask, colon, that's going to be an integer. Come outside of the parentheses, it's going to return an integer. We're going to open up the brackets and we're going to say mask dot zero, not mask dot non-zero bit count, and that's just going to get us all of the bits that are 1, right? So we're gonna the non-zero bit count. So we're gonna count all of the bits that are 1. We're not gonna count the bits that are 0. Boom. Then we're going to create a recursive DFS function. So for that, we could come right here. We're gonna say func DFS, open up the parentheses, underscore I, colon, integer, comma, underscore mask, colon, that's going to be an integer, say comma, underscore used change, colon, that's going to be a boolean, and then it's going to return an integer, and we're going to open up the brackets like this. So first we need a base case, to see if we reach the end of a string or one final partition ends here. So we're going to say if I equals n, then we could just open up the brackets and we could just return 1. Boom. Then we need to create a unique memo key for the current state. So we're going to come underneath this and we are going to say let key equal, open up the quotation marks. We're going to slash, do some string interpolation. So then we're going to open up the parentheses, pass in I. Then we're going to say minus string interpolation again and pass in mask, close the parentheses. Then we're going to say minus and do some more string interpolation. This time it's going to be use changed or use change. Boom, close it with the parentheses like that. Then we're going to come underneath this and we are going to say if let cached equals memo square bracket key. We're going to come outside of that. We're going to open up the brackets and we're going to say return cached. Boom. Now we're going to come underneath that, underneath this if, and we are going to say let cur char equal, it's going to be an int, open up the parentheses, we're going to say char square bracket I, come outside the square bracket, we're going to say dot ASCII value, exclamation point, then we're going to say minus character, open up the parentheses, quotation marks A, then we're going to come outside those parentheses and we're going to say dot ASCII value again. Then we're going to come underneath that and we're going to declare a variable called result, set that equal to 0. Boom. Now for option 1, we're going to continue the current partition with the current character and no change. So we could come right here, say let new mask equal mask, then 1 vertical line, and then we're going to open up the parentheses and we are going to say 1 less than, because remember we're dealing with bits, so we're going to say cur char. So this is just the bitwise OR. Boom, and this is the bit shift or the bitwise shift. Boom. Then we're going to come underneath this. We're going to say if bit count, open up the parentheses, new mask, come outside of those parentheses, less than equals k, so it's less than or equal to k. We're going to open up the brackets, and if adding this character doesn't exceed k distinct characters, we're going to continue. So we're going to say result equals max, open up the parentheses, result, comma, DFS, open up the parentheses, I plus 1. Then we're going to say comma, new mask, comma, used change. Boom. Then we're going to come right here. We're going to say else, open up the brackets. And otherwise, we must start a new partition. So we're going to say result equals max, open up the parentheses, result, comma, 1 plus DFS. Sorry, y'all. 1 plus DFS, open up the parentheses, I plus 1, comma, 1, less than, cur char, comma, used change. Boom. Boom. Okay. Then for option 2, if we still have the chance, we're going to try changing this character to something else. So we're going to come underneath this right here, and we are going to say if exclamation point use change, we're going to open up the brackets, and we're going to say for new char in 0 ... less than 26. Boom, we're going to open up the brackets because there's 26 letters in the alphabet. We're going to say if new char equals cur char, then we could just open up the brackets and we'll say continue. Boom. Then we're going to come underneath that and we are going to say let change mask equal mask bitwise or, so one vertical line, open up the parentheses, we're going to say 1 less than new char. Boom. Then we're going to come underneath that and we're going to say if bit count, open up the parentheses, pass in changed mask, boom, is less than or equal to k, so less than equal k, we're going to open up the brackets, and if changing the character still fits in the current partition, then we're going to say result equals max, open up the parentheses, result, comma, DFS, open up the parentheses, I plus 1, comma, change mask, comma, true. Boom. Then we'll come right here. We'll say else. We'll open up the brackets. And otherwise, we're going to start a new partition with the change character by saying result equals max, open up the parentheses, result, comma, 1 plus DFS, open up the parentheses, I plus 1, comma, 1, less than, new char, comma, true. Boom. Then we could come down here and we'll say memo, square bracket key. We're going to set that equal to result. Come underneath that, we're going to return result. And then we still need to call this function by coming right here, and we're going to start from index 0, and we are going to say return DFS, open up the parentheses, 0, 0, false. Boom. So that should be all she wrote, y'all. Let's give it a run before we submit it. Make sure there's no typos or anything like that. And of course there is, cannot find use change, need an N right here. Boom, let's run it again. See what happens this time. Okay, cannot find char and scope. Where's char? Where we at? Right here. So let's see. Oh, this should be chars, not char, sorry. I think, yeah, that should be chars. So now let's run it. See if that did the trick. Okay. So let's see. Cannot value must be unwrapped. Sorry, y'all. So this should have exclamation point as well right here. Let's run it again. See what happens now. It's accepted, so let's go ahead and submit it. Make sure it's still accepted after we submit it, because we all know how LeetCode can be. And look at that, y'all. 1,099 milliseconds beats 100% of users. That's what I'm talking about. That's what I like to see, y'all. So with that being said, make sure you get one more look at the code. This is the top part. This is the middle part. This is the bottom part, y'all. And yeah, with that being said, I hope y'all learned something today, and I hope to see y'all here tomorrow for another day, another LeetCode problem. See y'all then.